Hello everyone, today is Monday and today I would like to summarize what I learned last week. The first topic I would like to share is what's the difference among LLM, RAG, and AI agent. This is a topic I posted last Monday. So the key purpose of this post is to make us think what would be the correct or the proper technology framework to use, because if we can resolve the problems without using RAG, and then there's no need to make the system complicated. If our purpose is just to ask the general questions for LLM, then we just use LLM. But if we have the need to retrieve a lot of documents from the system, and we want the language models to answer the questions based on the retrieval result, then we can use RAG. For agent AI, it's a more complicated one. It not only can search for documents we want to have, it can also connect different tools and data sets and figure out the user's intentions and find out the best combinations of tools and data sets to help us resolve the problems. So it's a more advanced option. So this is a topic to tell us what would be the best way to choose the right AI technology framework to resolve the problems in our daily life. And following this, the rest of the posts I have is for automations of the running AI inference. So the first one I mentioned in this part is about the data type called NF4. So it's like a NF4 data type. It only takes 4 bits to save the model's weights. However, the key advantage of using NF4 is that it doesn't project a high precision data into low precision data in an even way. Normally, when it comes to NF4, we'll project data from high precision to low precision in an equal way. But because in the reality, most of the weights in the language models are near zero, so NF4 try to keep most of the informations near zero when we project high precision data to low precision data. So we follow normal distributions to keep the information around the values of zero. So that's the key idea of the NF4, saving the data by keeping the key information, even when we try to quantize the data from high precision to low precision. And then after this, I think it's on Friday and Saturday, I share the topics of the page attention and flight attention, and I try to link the two concepts, two ideas together. So when we run language model inference, we first feed the prompt into the language model, and then it starts the pre-filling status or stage. So in this case, we can use flash attention to accelerate the computing time. The idea of flash attention is trying to minimize the needed I/O between the GPU and memory, because when we compute something like a Q times K, then we need to send both Q and K from memory to GPU, and when it gets a result, then we need to send it back to memory, and then we get another vector called V, and we do send V and the result from Q and K back to the memory again to do another round of the compute. So it's like lots of the back and forth data pacing. So what flash attention tries to resolve is try to fuse the compute. So it's called the kernel fusion. So we can combine the different operations into one, and we do not need to send the intermediate result back to memory. We can finish everything inside the GPU, so we can reduce the need to send it back and forth between GPU and the memory. So this is a flash attention. Try to minimize the need to pass data. Try to minimize the efforts in the compute. So after flash attention, we would generate the KV cache, and the KV cache here will actually take a certain amount of the memory usage, and this is where page attention can help. Page attention is save the KV cache with the many small pieces of the memory, just like many pages. In this case, we can reduce the waste of the memory usage. Before using the page attention, we would need to allocate like a long amount of or huge amount of memory to save the KV cache, but we do not know what would be the right number to save the KV cache. But with the so most of the time it would found that we would waste a certain amount of the memory. But since we have allocated the memory to it, then it will cost something called fragmented memory, and it can make the saving, the memory saving, very inefficient. So to deal with this, we can define the page. Each page do not take too much memory usage. So even though we found that this page cannot fit in all the KV cache, we have something left, but it does not take too much size. So for us, then it can enhance the overall the memory saving efficiency. So that's the key idea of the page attention. So overall, no matter is data type or flash attention or page attention, the key purpose is to make sure we can run large language model in a more efficient way. And large language model is the fundamental technology to support RAG and agentic AI. So this is basically what I want to share through what I learned this week. Yeah, and hope you have a great time. Thank you for your listening, and happy and enjoy your AI learning time. Thank you. Have a good day. Bye bye.